Hi students, today I am going to discuss the 2D reflection technique. This is one of the transformation technique in 2D. So we already discussed three different types of transformation techniques, that is translation and rotation and scaling. Now I am going to discuss the 2D reflection. What the reflection is nothing but reflection is also a kind of rotation where the angle of rotation is 180 degrees. So here the rotation should be taken in the exactly the 180 degrees, that is which is parallel on the x-axis and similarly which is parallel on the y-axis. So that means exactly the opposite of the position which can be displayed the 180 degrees. So the reflected object is always formed on the other side of the mirror. So now we can observe the mirrors. So the object can be displayed the opposite side of the mirror. The opposite side in the sense, so the object should be taken the reverse order. If the left is right and the right is the left position when we take the mirror order. So now let me consider the size of the reflected object is the same. So here one more key point in this particular reflection 2D reflection is, so the object cannot be changed. So the object size is the same which can be reflected to the other side. So that's why it takes the 180 degrees. So the 180 degrees exactly which is takes the position on the below order, that is the mirror order, and also we have to be observed the size cannot be reduced. So one more key point here is, so the reflection takes on x-axis and reflection takes on y-axis. Here both can be happened in this particular 2D reflection concept. So coming to this, already the standard notation of this particular consider the point object O. So the coordinates of the object O equals to x volt and y volt, and new coordinates of the new coordinates after applying the 2D reflection. So then we can derive the x new and y new. So how to find the new coordinates which is reflection on x axis and which is reflection on y axis. So both are a different manner. Now we are going to take the reflection on x-axis. So the reflection on x-axis means, so whatever the object which is reflected on the opposite way, so the apply of that particular x coordinate, so simply we can assign the new coordinate is the negative value. So that's why the 180 degrees is come to the bottom of the x-axis. The bottom of the x-axis is taken the values coordinates of the negative sign of the y value. So for example, I just considered one of the graph, like suppose this is an x-axis and y-axis. So x-axis and the y-axis. If the object here located, the reflection takes place exactly the bottom of the x-axis. The x-axis value cannot be changed, but the y value here is the negative value. Here is the negative value and y value here is the positive value. So now you can estimate it, whenever the object is reflected on this particular x-axis, the y value becomes to the negative. So if the same object which is reflected on the y-axis, the same object which is reflected on the y-axis, so the y-axis value is the same, the negative sign will be taken in the x-axis. So this is the key point of this particular concept which we have to be applied. That's why the reflection on x-axis in the sense, so here you can observe the reflection on x-axis in the sense x new equals to x volt. So whatever the new object is derived in the x-axis, the same value which is displayed, but coming to the y value, the y volt new equals to minus y volt value, because the negative sign can be considered in the y-axis. So similarly you can observe, so this is the notation of the matrix order. So whatever the reflection takes place on x-axis, x new y new equals to 1 0 0 minus 1 sign. Here why we can put the minus 1, because the y value sign will be the taken after reflection is the negative value. So that's why here 1 0 0 minus 1 into x volt and y volt. So this is the reflection matrix after applying the reflection on x-axis. And similarly, so this is the homogeneous matrix. So we can apply this homogeneous matrix for this particular reflection taken place on the two-dimensional, and similarly, so we can consider this particular process so for the x-axis, and similarly we have to consider the reflection on y-axis. So when we take the reflection on y-axis, I already give one of the simple notation here. This is an x-axis, y-axis. The y-axis is located here. If the object will be the reflected on the y-axis, so the y-axis position, so which is the value is the same, which does not change. The opposite sign, that is the x value, is the negative value here. So it will be the focus value is the negative. That's why here we can consider the notation x nu equals to minus x volt, y nu equals to y doesn't change the value. That is x nu value is similarly the y volt value. So we have to consider the matrix notation in the following order: x nu and y nu. So where minus 1, 0, 0, minus 1. Minus 1 indicates what? So when we take the reflection on y-axis, the negative sign will be taken on the opposite axis, that is the x. That's why minus 1 here we can take 0, 0, 1, and similarly this is the x volt and y volt value. This is the reflection matrix which is related to the y-axis. This is the homogeneous equation when we have to be considered on the y-axis: x nu, y nu, and 1, minus 1, 0, 0, 0, 1, 0, and 0, 0, 1 into x volt, y volt, and 1 watt. So this is the reflection on y-axis homogeneous matrix. So now we are going to discuss a small example. So what this particular reflection takes place on x-axis, and similarly the reflection takes place on y-axis. Now we can consider the given a triangle. So what the object here given is the triangle. So a of 3, 4, b of 6, 4, and c of 5, 6. Now we are going to apply the reflection on x-axis. You clearly identified the problem is given. The reflection takes place on x-axis and obtain the new coordinates of the object. So now we have to be considered the initial coordinates of the triangle. The triangle considered the three coordinates, that is an a of 3, 4, b of 6, 4, 5 of 5, 6. That is a given data. Now the reflection takes place on x-axis. Specifically the problem is given, the reflection takes place on x-axis. So we already discussed that reflection takes place on x-axis. So x value is the similar value, but only the change of the coordinate value is the y value. The y value should be the negative. So that's why here x nu equals to x volt. So the similar value is taken, no change of the x value, because the reflection takes place on the x-axis. So that's why the 3 value is taken. So y nu equals to minus y volt. So the opposite value we have, the negative sign value is taken in the y coordinate, that is a minus 3. So what are the new coordinates after applying the reflection for coordinate a, 3? Here we can observe in the triangle 3 coordinates are given. So we can apply the each and every coordinate. A coordinate can be applied on x-axis, and x-axis is taken for b, and y-axis taken for the c coordinate. Now similarly we can find the for coordinate b of 6, 4. So the x value signing is the same, that is the same x value, x nu value equals to x volt value, and y nu equals to y minus y volt value, that is minus 4. So now we have to derive, now we are derived the coordinate b 6, 4 after applying the reflection, then it comes to the 6, minus 4. And similarly for coordinate c of 5, 6, so then we have to take the negative sign of the 6 and 5, minus 6. So this is the c value. After applying the, now we will go through this diagram is clearly. So this is the initial object. See here, this is the initial object for the given coordinates ABC, original object. So whatever the object is given, so that is this object. So now this will be reflected 180 degrees. This will be the reflected 180 degrees in the mirror concept. So here the mirror, so the opposite, you can see the position of the object. The position is here, so simply it can be take the reverse order of the position. So here whatever the values we have to be taken, so the object may not be changed. The only change in the sense the position is the 180 degrees in the opposite way. So you have to observe the similar object is displayed on the below x-axis, because what the given problem is nothing but the reflection takes place on x-axis only, not in the y-axis. So that's why we can derive the final one. So this is the reflected object. So in this reflection, the reflection takes place on x-axis and reflection takes place on y-axis. So once again I will repeat the important statement in this particular reflection, 2D reflection is, when you apply the reflection on x-axis, the x coordinate is the similar, so y coordinate change the negative value. So when we take the reflection on y-axis, the y-axis is the similar and we have to take the negative on the y-axis. So we are going to discuss one more transformation technique. So that is the last one. That technique is going to be explained in the next video. Thank you.